Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble code DTC P1297, which indicates a low voltage condition in the Electrical Load Detector ELD circuit for the Honda Accord models from 2008 to 2012. The ELD is a crucial component that measures the electrical load on the vehicle's electrical system and communicates this data to the Engine Control Module, ECM, or Powertrain Control Module, PCM. By doing so, it plays a vital role in managing the vehicle's electrical supply, helping optimize performance and fuel efficiency. When the ELD circuit does not supply the intended voltage, there could be disruptions in the car's electrical systems, leading to performance issues. Understanding DTC P1297 is essential for both diagnostics and effective repairs, ensuring that the ELD operates correctly and communication with the ECM, PCM remains uninterrupted. The error description associated with DTC P1297 concerns the Electrical Load Detector, ELD, and its ability to properly relay the current electrical load to the Engine Control Module, ECM. The ELD is typically located near the battery or in the vehicle's fuse box. Its primary function is to monitor the electrical requirements of the engine and various electrical components, sending voltage data to the ECM. If the voltage reading falls below 72 amperes, it may trigger this error code, signaling a problem within the ELD circuit or connections. The ECM, located under the dashboard and connected to numerous sensors and actuators, processes this information to manage engine performance and efficiency. Any issues found in the ELD may lead to insufficient electrical supply, affecting essential functions in the vehicle. The potential causes for receiving DTC P1297 include several factors that may compromise the ELD's operation. One primary suspect is a faulty electrical load detector itself, which may be responsible for the low voltage reading. Another consideration is the presence of poor connections or loose terminals, especially between the ELD and the Engine Control Module, ECM, or Powertrain Control Module, PCM, which can interrupt the signal flow. Additionally, a short circuit in the wiring between the ELD and the ECM may directly lead to an incorrect voltage reading. Each of these causes needs to be evaluated through systematic troubleshooting to ensure connectivity and functionality. Properly identifying the root cause allows for precise repairs and ensures the smooth operation of the electrical system. Symptoms associated with DTC P1297 may illustrate underlying problems within the electrical system of the Honda Accord. Drivers may notice engine performance issues, which could manifest as decreased acceleration or unstable idling. Electrical inefficiencies may surface, impacting the operation of various electrical components and accessories, such as power windows and lights. Furthermore, dashboard warning lights may illuminate, indicating a malfunction in the electrical system. These symptoms may appear sporadically, contributing to the challenge of diagnosing the ELD circuit problem. Paying attention to these signs ensures timely intervention for any significant operational interruptions before they escalate further. The first troubleshooting step for addressing DTC P1297 involves turning the ignition switch to the on-to position, which powers the vehicle's electrical system without starting the engine. It is essential to record all freeze data and any onboard snapshot at this stage, as this data provides insight into the vehicle's previous state, which can be critical when diagnosing the issue. The next action is to use the Honda Diagnostic System, HDS, to check the Electrical Load Detector ELD data in the data list. Specifically, it is crucial to see if the amperage reading is 72 amperes or higher. If this condition is met, the troubleshooting will advance to the next step, Conversely, if the amperage is below this threshold, it indicates an intermittent failure, suggesting the system is functioning properly at the moment. After the first check, turn the ignition switch to the lock 0 position to cut power to all electrical systems. Next, the 3P connector of the electrical load detector, ELD, needs to be disconnected, allowing a clear path for further diagnostics. Turning the ignition switch back to the on, option 2, position once again enables system checks. At this point, you should again check the ELD in the data list using the Honda Diagnostic System, HDS, to see if the amperage now reads 72A or higher. This is critical as it checks the ELD's performance under different conditions. If the amperage meets the specified criteria, troubleshooting proceeds to the next step. If not, move to the next part of the evaluation, keeping in mind potential intermittent issues. Following previous steps, the ignition switch is turned to the lock 0 position again to ensure no power is running through the vehicle's systems. It is then necessary to jump the SCS Service Check Signal line with the Honda Diagnostic System, HDS. This step enables further diagnostics to check the communication between the system components accurately. After that, the ECM-PCM connector A, specifically the 49P connector, needs to be disconnected. This action helps isolate the electrical load detector from the rest of the system, ensuring focused testing of the ELD circuit components. Disconnecting the ECM-PCM allows technicians to check for issues without interference from other electrical elements. At this stage, the critical task is to check for continuity between the ECM-PCM connector, terminal A24, and the vehicle's body ground. This continuity test is essential for determining whether the circuit is complete or if there is a break in the wiring. If the reading shows that there is continuity, it indicates a closed circuit, allowing you to move forward to the next step, which involves repairing any shorts found in the wiring between the ELD and the ECM. Conversely, if continuity is not present, it signals a problem, specifically a likely open circuit. In this case, further investigation is necessary to trace the wires, pinpoint faults, and ensure consistent electrical flow between components. If continuity testing indicates a problem, the next logical step is to return the ignition switch to the lock 0 position. If deemed necessary based on troubleshooting and test results, replacing the electrical load detector, ELD, becomes essential. A faulty ELD can lead to continuously low voltage readings, impacting overall vehicle performance. After replacing the ELD, re-establish all previously disconnected connectors, ensuring secure and proper connections. Each connector should be checked for dirt and ensure no bent pins are present, as these could lead to further issues. Once these steps are completed, the system moves on to the critical phase of system resets and learning procedures. Once all connectors are reconnected and secured, the ignition switch should be turned to the on 2 position again. This action allows the electrical system to initialize and be prepared for the next process. The next step involves resetting the engine control module, ECM, or powertrain control module, PCM, using the Honda Diagnostic System, HDS. This reset is crucial as it clears any stored error codes, enabling the ECM-PCM to start fresh and read current conditions accurately. Following the reset, performing the idle learn procedure helps recalibrate the engine management system for optimal performance. This procedure involves various inspections to ensure that the engine can idle correctly with the new ELD operational. After completing these actions, the vehicle is one step closer to being fully operational. Following the completion of the previous steps, it is imperative to start the engine as part of the final verification process. Observing the engine running helps confirm that the system is functioning correctly after the repairs to the ELD and any related wiring. Turning on the headlights serves to put a load on the electrical system, allowing you to monitor its response closely. It is essential to scan for DTCs again using the HDS to ensure that P1297 does not reappear. If the DTC comes back, it indicates that further troubleshooting might be needed, suggesting the issue hasn't been entirely resolved. Proper verification is essential to guarantee that the initial problem was properly diagnosed and remedied, ensuring overall vehicle reliability. Preventive maintenance plays a significant role in avoiding issues like DTC P1297 from resurfacing in the future. Regular checks of the electrical system can help identify loose wires, corroded connections, or other wear and tear that may affect performance. This proactive approach involves inspecting ELD connections specifically, which are prone to environmental damage and debris accumulation. Should any problems or inconsistencies arise in voltage measurements or electrical functionality, replacing the ELD might be necessary to prevent larger issues down the line. Regular maintenance checks not only ensure that the ELD operates efficiently, but also contribute to the overall longevity and reliability of the Honda Accord's electrical systems, preventing future complications. In conclusion, effectively diagnosing and resolving DTC P1297 requires an understanding of the electrical load detector's role in the Honda Accord's electrical system. By rigorously following the troubleshooting steps outlined, technicians can accurately pinpoint issues and address them holistically. Proper testing and replacement of faulty components, particularly the ELD and its wiring, are crucial for maintaining system functionality. Moreover, implementing regular preventive checks not only aids in early detection of potential problems, but also ensures the overall health of the electrical system. Comprehensive knowledge, combined with diligent practices, ultimately leads to enhanced performance and reliability of the vehicle, minimizing the risks associated with electrical faults. Please like and subscribe to the channel. See you next time.